So I request you all to close your laptops because this is a talk and demo session. So you will be listening primarily to what is upcoming. So I would request everyone to close their laptops. So in the previous session, we saw how a security threat can be in a dependency. Now let's see how a security threat can be at a request and a response header level. So we can stop the security threat at the as a first level of entry into our application itself. So now we have Deepthi presenting to us security headers, build them stronger.
Hi everybody. So yeah, security headers are very important from a service point of view because the World Wide Web, right, it has a lot of things and there is not much restriction that's available. So it's always the responsibility of the server to say that, okay, protect myself from, to say to the browser that I have to have so much of protection in this vulnerable place. I think security headers is something that everybody who's into web development and testing has to have a good idea about because you get to come across all this. Although a lot of frameworks have them already built in by default, say a Rails or a Java-based framework, they'll always have some of the headers built in by default. But I think it's good to know what they really do, so that we don't mess up with them and we need to build more on them. So the focus of the session will be on headers, and in some cases, right, if there's no possibility of using a header, I will be talking about security best practices that can be taken up. Yeah. The different issues that we are looking at are these. We will go through all of these now, and I'm not going to detail on it now. So the storyline is, let's say we have a fictional breach. I have a website developed, which is a blogging website. It has a lot of posts. By generally it allows people to register to the website and create posts. And they have a new contest that's happening, and whoever has become a creates a trending post with a lot of votes, right? They have a chance to win $1,000. So now people start writing to the blog, and let's see, there is one person. So the website's name is mywebsite.org. So there are so many posts that are there. I have labeled the trending post as trending post and the attacker's post as the attacker's post, just for us to understand. So if you see the number of votes for this trending post is 4. So every user can create vote for this post, and the attacker's post has not got any votes. So now he's really interested in getting this cash prize, and he tries to attack this vulnerable website, not in the right means, but try to hack it through and then get more votes. That's the intention. So with this in mind, we'll see what are the different vulnerabilities that are existing in the website and how we can secure them with the headers, right? I'm not having this in the presentation mode because I will always have to shift between demo and this. So we'll start off with the CSRF, which is cross-site request forgery. Before even I talk about it, I'll start with what a same origin is. So a same origin is always needs 3 things. One is the protocol, which is HTTP or HTTPS. The other is the host. The other is the post. This triplet defines whether 2 different websites are of the same origin or not. So if you take www.example.com, this is one website, and let's compare it with the other websites and see whether they are of the same origin or not. So the first 2 things which are highlighted in green, right, are of the same origin because they have the same protocol, which is HTTP, same domain, and same port. The only difference is they have different paths, so they are of same origin. If you look at the other 3 websites, right, one has HTTPS, so they are not of the same origin. The other has a port 81, which is of different origin. The other is completely different website, so they are of different origin. This is one basis that we need. And also, let's see how a session works in general in web applications. So I, as a user, log into a website. using my browser, and there is this web server. So what happens? I first log in with it using my username and password, and the server first validates, checks whether it's right or not, and if it's right, it sends back a cookie to the browser. So now, from now on, the user does not validate every time with username and password. Rather, the browser just sends the cookie that is stored in the browser, and the server looks and checks if it's the right user's cookie, and then it responds with all the requests. So, be it Facebook or whatever website you're doing, if there is always a session that's added to it. So now, if you look at this website, right, I've signed in as 5@gmail.com. This is the user ID thing. And since I've signed in, if you look at the application and cookies of mywebsite.com, there is this blog session. This session value will always be sent by the browser, irrespective of whether the user wants to or not. This is always sent, and that's how the browser knows this user is logged in, right? So yes, so where is the vulnerability existing? It's all in the browser. If the browser doesn't know this, doesn't have this cookie, right, it will not be able to find out whether this user or not. So if an attacker is trying to attack the website from the user's point of view, if he wants to hack a user's account, he should have this cookie in place. So if the attacker tries to attack this website from this machine, but from a different browser, let's say he tries to attack through Firefox, he will not have the cookie. He cannot have the cookie. He cannot do anything. Even if he does it within this browser, but on a different website, let's say he attacks from attacker.com, he cannot basically take hold of this cookie base because it doesn't allow something called as something because of a policy called same origin policy. So all browsers have the same origin policy in place, and the only vulnerable thing is the browser because that has the cookie. You cannot attack from a terminal because that does not have a cookie. From any place, rather the browser is the only problem, and only thing that has all the ownership. So to just before understanding what same origin policy is, let's look at the history of web. So how does the web? Why did they start web? They want some set of people wanted to interact between them, send information, create some static web pages, talk between different servers, and that's how they wanted the web to come into place. So back then, they were all static web pages, and they didn't have much problems with it. And as time moved on, we brought in dynamicness, we brought in JavaScript, and we also had problems to deal with. So when people are not restricted, what happened is people from different websites, right? They started accessing information from another website. So if I, as a user, log into from my browser, access two different websites. One is my banking account, and one is another website. So this other website will be able to access my bank account details if I'm logged into it. Because there was no policy in place, these people started using JavaScript to read account balance, try to change username and password and all that. So they tried stealing credentials and important credentials and all that. And that's when they thought, okay, let's have some policy in place to protect the authenticated people and not let the attackers do anything. On the same origin policy, let's say if we were to build the same origin policy as a group, we want to stop people from doing this in such stealing of information. What do we do? Let's say we have a strict policy in place. I have a website. So for the understanding purpose, my website is legitimate website is my website, and localhost 8000 is attacker's website. Let's say these are the two websites that we have to look at. So the attacker, let's say the attacker has some page in place. So let's ignore the attacker's point of view. For now, to understand the same origin policy, right? There is this page which is hosted by localhost 8000, which is the current origin of the website URL. If you look at this page, there is this link called private browsing, which points to Mozilla.com, and there is one more link which points to support.google.com, and there is one more image that's embedded here. If we are to design a very strict same origin policy, right, from the browser's point of view, it has loaded localhost 8000, and it's trying to link to Google and Firefox and other websites information, right? So by default, I would say, okay, I'll not allow any origins to be accessed from this origin. So from the browser's perspective, from localhost 8000, we are trying to access two different websites. So if it stops at this level, right, then the web will not exist at all. All the links will not happen. All the images will not happen. So they wanted to have a very relaxing policy, but not let the credentials to be stolen also. So how did they design it? If you look at the same origin policy, so there are three types of policy, which is, so when we are trying to access the information of another website, it's called as a cross-origin request. So if you look at the link example, the images, the videos, that all happens in generally we link to, right? Which are not very sensitive, but we just want to link to for reference purposes. That's called as an embedded cross-origin request, where from the browser's point of view or from the user's point of view, he will be able to see the information, which is so I as a user, I'm able to look at this information, but from the server's point of view, right? If this is an attacker's website, there are two things. One is the browser which the user uses, the other is the server of the attacker. So the user will be able to see all this information, but if I do $.get, which is basically an API request that happens from the server. If the server tries to get the information of this link of Firefox and do something on it, right? If it does this $.get, if you look at it, it actually stops. So two things are here. One is embedding and another is reading. The embedding is just displayed in the browser, but not get the information about it. The server can never get the information using JavaScript. So when the server does a cross-origin request, the browser blocks it, saying, okay, you're not of this origin, and you can never read the information into your server. So let's say there's a bank account, and the bank account's information is the server is trying to access the bank account's credential and use it in a server. He can never do that. So if this is my browser, I have logged into bank account, and I also see a link to the bank account. I, as a user from my browser, I can see that link. That is embedding. But from the server's point of view, the attacker from somewhere else in the world, and from his server, right? If he tries to look at it from doing this get request, he can never get the information because it stops him from looking at it. So this is the embedding and linking of cross-origin. So yes, having such an idea about it, we'll see what all are possible and what is not possible. So there are two different origins of two different websites with two different origins. Can the attacker website read through the DOM of my website? He can never read through my website. Even if I log in, from the same machine, the attacker can never look at my DOM. They can never read and write cookies. The cookies are all specific to websites. They can they do a GET request to a different domain, just as we saw now? They can never do a GET request using JavaScript, but they can still embed links, they can still embed images, they can still embed videos. And they can still do one more thing, which is the vulnerability that we are going to talk about, which is CSRF, which is they can send the cookie of a domain to its own domain. By this, what do I really mean? Now we saw from the attacker's website, we are trying to do a GET request to another domain, right? The browser blocks it. But what really happens in the background? Let's have a look at it. So coming back to our website. So there are a lot of posts, and what this attacker does is he looks at the trending post and he goes to it, and he has added a comment to this trending post with the link of that attacker. So he does a legitimate, some very intentional or very interesting comment to this discussion. And there, to know more details, he says, click on this link to more details. This is the attacker's website. So by the time the users click on this, right? 1 minute. So, this is the server logs. Let's look at two things here. The user is logged in as 5@gmail.com. The trending post has 4 votes, and the attacker's post has 0 votes. Now, the attack that we are trying to talk about is, by the time I click on that link of that attacker, what actually happens is, the attacker using this user5@gmail.com, he downvotes the trending post and upvotes his post. That's the attack he's trying to do. So if you look at this attack, all that he wants to do is he has to add a comment to the trending post, and anybody who looks at the comments of the trending post, and then any user clicking on that link will actually downvote. If he has already voted for that post, it will downvote and also add a vote to the attacker. That's the attack that he's trying to do. Before I show the demo, I'll also show what happens. So when on page load, basically on window load, when the user just clicks on it, there is one JavaScript that gets executed, which is basically a call, which is a post call to downvote the current the trending post vote. And there is also one more thing, which is to upvote his question. If you look at it, right, how does this all happen? This all is happening because the user is already logged. Some user is logged into the website, and there is this cookie that's stored in the browser. Right now that the cookie is stored in the browser, what the browser does is, from the browser's point of view, any request that goes to the proper mywebsite.org, if you do a request to it, right, what the browser thinks is, okay, this user with this machine, with this the logged in browser, is doing a request to my website. So let me send all the cookies to my website also. So what it does, it just sends the cookies. From the server's point of view, okay, there is a request coming from the client, and it also has the cookie. So I'm thinking this is the right person, and I also allow it to happen. So, so what is the only problem here? The request is not happening from the user's knowledge. Rather, it's happening from an attacker's website. The user never knows it. Since he is visiting the attacker's website, is able, the browser sends the cookies to the server. What the same origin policy actually stops is, it does not send any cookie to attacker's website, but it always sends a cookie to its own website. There's a slight difference to it. The cookies will always be sent, let's say there is a map between the cookie and the URL. Whenever there is a request happening to a proper URL, all the cookies associated with that URL will be sent to that server. So from the attacker's website, if the attacker is doing a call to the mywebsite.org, all the cookies that are part of mywebsite.org will be sent to my website server, not to the attacker's website. Although it is sending the request. So what is the problem with a post call? You can always do a change. So with the 2 post calls that are happening here, right? I'm downvoting and I'm also upvoting. So there are 2 changes that happens. Why isn't the browser restricting anything? From the browser's point of view, it always sends the request, but it only does not show back the content here. So if I go to that CS thing, so this page loads, and as the page loaded, there was a downvote call happening, and I'm also having a user-driven click. So when I click on this, there is also an upvote call happening. So getting back to the blog, there were 4 votes and 0 votes. Now we have refreshed, there are 3 votes and 1 vote for the attacker. So as and when people click on this website, from the comments, the attacker will get votes, and the trending block will have downvoted. This is the CSRF problem. So
can you just explain that part once again? When user clicks the attacker's site, how does the attacker gets cookies from the browser?
Yeah. So this is the attacker's website, right? If you look at it, I click on it again. there is a network call that happens to mywebsite.org, if you see. So the call happens because there's a JavaScript in the attacker's website to call it. From the browser's point of view, there is a call to mywebsite.org, and browser thinks, okay, there is some request to my website, let me do that. It does not check the origins. It does not check whether it is an attacker's website or it's the right website. It just thinks, okay, there is a website call happening. Okay, let me do that.
Okay.
So the call actually happens. Since there is a cookie also associated, because the user is logged in, the cookie is also sent. And the actual post also happens. So how does the browser protect here? If you say, okay, the browser does the same origin policy, but there's no protection in place. All the browser does is, browser just just stops from showing back the response. So it says, okay, there is a cause that has happened, and I'm not showing back the response. Whether it's an upload happened properly or not happened properly, the response will not be shown back. This is because I said, right, they were not able to bring in a very strict policy in place when they brought in same origin policy. Because a lot of, by the time they wanted to introduce same origin policy, a lot of websites wanted, already had cross-origin form posts and all happening. So if they stop this, then it will be a big problem for many websites. So they said, okay, let me make the servers deal with this problem. So instead of the browser checking for the origin, whether the origin came from the right place or not, we let the server to do it. That's why the protection comes into place. If you ask me, are all the requests vulnerable? They are not vulnerable. Only the ones that were created before the same origin policy. Basically, the get calls and the post calls with such content types, which is form and form data and text plain content types, are vulnerable. With the new things that came up recently after the REST APIs, right? The post with application JSON, put, patch, delete, which are actually very critical compared to the normal posts. These are all protected. If you ask me how these are protected, generally what the browser does is, let me come to the not so simple requests now. So if there is an update that's happening or a delete that is happening, the browser just checks for the origin. If it says, if there is a difference in the origin, the browser first does a pre-flight request, something called as a pre-flight request, which is a request that it sends to the server, saying there is an attack, there is a call happening from a different origin. Do you want to allow this person or not? That is when there is something called cross-origin resource sharing, where you add headers from the server saying access control allow origin. Again, there is one header which the server can say, that's saying that I want to allow my website or to be accessible from attacker.com. If I, as a server, say that this is allowed, then this pre-flight request will be able to understand, okay, this origin is allowed from the server, and then it will actually do the actual call. So there are two things that happens for this not so simple request. First, a pre-flight request happens, and the server says, yes, this origin is accepted. Then the actual call happens. But for these simple and post, the simple requests like get and post, which is on the top, this two-way request does not happen. The pre-flight does not happen. The browser leaves it to the server to handle. Right?
In this case, is it because that navigation was there, is it a problem? Or because when we navigated to the new page, the origin would have already changed.
Origin would have changed, and the browser knows it, but the browser does not restrict it for the simple request alone. The browser restricts it for the post, put, patch, and delete, because it knows that this is a different origin. Because the browser has all the information, it knows there are different origin, and it stops there itself. It just does the pre-flight, and then only after server says it's right, it will do the actual request. But for the simple requests, since it didn't want to bring in a very strict same origin policy into place, it actually, even though there is a different origin, it sends the request to the server. So it's up to us to protect ourselves from CSRF for these two small, simpler requests. So I'll actually touch upon how we will protect from this problem. So from OWASP, there are a lot of mitigations available. So if you look at it, there are two things, right? Get and post. The get is not a problem until we design the APIs properly. So for get requests, right? If you're not doing any state changing thing, get is supposed to take information and then show it to the browser, right? If as a developer you're not doing any state changing request, And if it's just showing the information back to the browser, then using same origin policy, we are protected because, like I said, the request actually goes to the server. The server responds with the proper response, but the browser will not show the response to the user because it's of a different origin. But for a post, right, even if the browser shows the request response or not, the post actually changes things. Like we saw the actual download happen. Even if the user is able to see the response or not, the actual problem happened. The general examples are banking websites where people's account balance, account money, right, is transferred to the attacker's account. Just because the post can change things in the background and there is no response shown back, the user will never know that there is a call that happened and something changed there. So GET requests are always protected until we don't design them to make any state changes. Coming to the post request, right? I just want to have a quick analogy on this. Say we are going to our home. I'm going to my house. People in my house recognize me because I have this. They know my face, right? But there is one more person who comes like me and gets into the house. Then how do they differentiate? That's how this problem is with the server also. Because the browser is sending the cookie that is authenticated. From the server's point of view, it knows that, okay, this cookie is the right cookie and it will always allow because it thinks it's the right person. So how do we differentiate? There is something called this synchronizer token pattern, where we say, okay, there is some conversation between my people in my house and say there is a secret code that I always have. So this person who's impersonating me, right, he will not have the token. So whenever I get into my house, I save this token. If this right, they'll allow me inside. So similarly, the synchronized token pattern, right? Whenever there is a person who is logged into a website, what we have to actually do is create a token called let's say we'll name this as authentication token. So this token that should be generated from the server, and I'll also from Rails point of view. I'll fix this. So I'm adding a CSR meta tag, and I'm also saying I want to protect from forgery. So whenever the website shows a form, basically a form from original website, the form will always have a hidden token in it. Since the DOM is not accessible by any other website, according to the same origin policy, the attacker's website cannot access the DOM. So this original website will have this unique token. And whenever an attacker tries to access the same post call, he will not have that token in place. And because of that, he will not be able to do a request. I'll also take the logs. So now I'm just editing this post. If you look at it, because I added the I protected from forgery, there is this authenticity token that is created along with the form. Right. So from my website.org, this authenticity token will always be sent during a simple post call. And from an attacker website, he does this same call, right? Where let's also go there. Now I'm clicking on this. So it throws up. It's from the server, right? It checks for the authenticity token from the attacker. Since it's not giving any token, it says invalid authenticity token and does not proceed request at all. So this is the button that I wanted to talk about. There are other mitigation strategies available. In the interest of time, I'm not showing it, but I will just discuss.
Basically, Rails has a default support for this.
Yes, Rails has most of the frameworks will have this. Yeah. The other is checking the origin. Like somebody asked, given that the browser knows there's a different origin, we can also from the server, right? The server knows its origin. So if there's a request that comes from a different origin, me as a server, I can say that, okay, I'll not allow this origin at all, which is where I have this nginx con. I've commented this out, but this thing basically checks for the referral and checks whether it's from my website or not. And if it's not from there, right, if it's from a different attacker's website, then I just return some code that does not allow future processing. So this is one way of doing it. There are other mitigation strategies also. There is one new thing that has come up, which is same-site cookie, which is a new thing that Chrome has come up with, which is only if a request is authenticated, started from the right website, it will send that cookie. It will not send the cookie from an attacker's website. It's something that's newly come up. It's not supported by all the browsers. And moving on to the next attack, if you have any questions. Okay. So there's this attack called clickjacking attack. This is UI-based CSRF attack, I would say. So if you look at it, there is this legitimate browser, which is oaf.com, and there is legitimate website is bank.com, and there is this OASP page that's coming on top of it. So what the attacker does is the attacker loads the original page in the background and makes it invisible for the user to see. And on top, right, he will just have some way of making the user click on it, and the user will actually be clicking on the original website. So I think with an example, you'll be able to understand it better. So the attack that to the story that we have, right? The attack that is trying to do is he'll make the actual user delete the post. So there is this trending post that's happening. Somehow, if I can make the user delete this post, right, only he can delete it, and if he deletes it, then I can get the price. So again, I have the attacker has added one more comment for clickjacking to the trending post. So somebody clicks on this. If you can look at it closely, we are asking the user to just click on this for joining the discussion. But in the background, right, if are you guys able to see this? There's this destroy link that's there. The user might think he's not done. He's just clicking on this link, but he's actually destroyed. Where's the last? Delete. It will actually delete the post. Yeah, that's the whole idea behind it. So you'll make the user click on something, and basically if you can delete the post itself by clicking, this can happen. So the vulnerability here is where the website actually allows itself to be loaded in an iframe state. So we can have a header from the server saying I don't want my website to be loaded in an iframe, or my website can be loaded in an iframe if it belongs to the same origin. So this is this header which you can add to the nginx configuration. So we add this, right? This page will never get added to the, it will never get loaded in an item. The next thing is XSS protection, XSS attack, which is one of the main things in WASP's top 10. So XSS attack is an attack where, now we have the same origin policy in place, and the server also has the CSRF protection in place. So an attacker from a different domain can never attack the website. We are stronger there. So what else can the attacker do? Can execute some scripts from the same origin. Same origin meaning from his website itself. From my website, if I can do some JavaScript happening, then the server will not be able to find the trawl because the request actually came from my website. So that's the XSS attack. We'll have a demo and see what happens. So there are different kinds of XSS attacks. One is persistent XSS. The other is reflective XSS. I'm showing persistent XSS, which is the attacker creates one more post in the website, and he creates the intention here is to reduce the credibility of the website. Now he thinks, okay, this trending post is going really high. Now I want to make this user leave the website. So if we can show this website is hacked, right, then proper users will not come to the website. So this is a CSS-based XSS attack where the attacker just loads CSS as the content. And if you go to my website.org, if the user comes and right, it will be like this. And which means the credibility of the website will go down and people will stop coming to this website. And that way he can do whatever he wants on adding more posts and make people work on it. So this is one way he can attack. The other is using access. Actually, access is very problematic. So you can also hijack sessions with XSS attack. I'll show how a session hijacking can happen. So I'm like the CSS that I loaded, I'm loading a JavaScript now. So what this does is whenever this post is seen by people, right, it actually calls the attacker's website with the current browser's cookie. Because this happens because the user is actually visiting the browser with the actual mywebsite.org. So whenever there's a request that's happening, there is no cross origin here. It's actually happening from the my website. So this script will be able to access the cookie because it's from the correct origin. So if we look at the red thing is the attacker's web server. So if somebody comes to this page, the attacker gets the cookie because we are sending the cookie in from the document. So I just from the attacker just has to get the cookie, moving in an incognito mode. You can visit the website. It's not logged in. He wants to log in as that trending post user. So he's got the session. All that he has to do is go to the application, change the cookie he got, and he'll be logged in. So XSS is the most vulnerable thing I would say. They can access anything from the DOM because the browser restriction also is not happening. It was the same website and you can do anything with it. So how do we protect this? XSS can be protected at different levels. One thing I wanted to highlight from the start is these protections, right, are not replacements for the other secure coding practices that we do. These are one more level of defense that we can bring in. So XSS can be protected at different levels. The level that we are talking about here is the header level protection. So we have this header called content security policy. What happens if we enable this header? Let's see that also. This header, I'm doing it from Rails. I'm not doing an Nginx-based header, just because there are various ways we can do this header. So I'm adding this content security policy and saying by default only allow any scripts that happen only from my website. Don't allow any JavaScripts to be loaded from another website. So if you look at this attack, right, that we added, there is this style sheet is loaded from attacker's website. So if we add this policy in place, it will not load a style sheet from a different URL. It will always load style sheets from my website, all JavaScripts from my website, all of it from my website. So this is the default thing, but you can also overwrite. Given that I believe Google fonts.gstyle.com is right, and I want to use that font, I can say, okay, I am whitelisting this URL apart from myself website. This is something that we can do. I'll come to the script SRC quite in 5 minutes, but let's see what happens with this content. So one thing content security policy is strict on is it does not allow any inline scripts to work. If you look at the website from the browser's point of view, if we look at this post, right, from the browser's point of view, there is one more XSS that's there. There is one more script that's there. I'm reading this post. If you look at the source of this post, okay. So what I mean to say is from the browser's point of view, right? If you have a script tag, if you have an HTML tag as part of a content also, as part of a comment also, the browser will look at the entire content. For it, it will also be HTML that it has to render, right? So what CSP content security policy does is it actually says, okay, I want to externalize all the scripts. I will never allow an inline script to happen because we just saw a comment with the script also is getting executed. So from CSP's point of view, it will never allow inline scripts. It will always allow scripts that are externalized. And if we have a policy like this, which says always default to self, so it will always load style sheets and JavaScripts only from my own website. One thing that I want to highlight is the inline scripts and inline JavaScripts that are not allowed, right? Is because here as part of the content, if you can have one more script tag, that will also be executed. So we are saying no to scripts and no to inline scripts and inline style sheets. So this, if we get back, since this is an external style sheet, this will not be loaded. If you look at the console, it will say refuse to load style sheet because it violates the content security policy. So it will not allow loading any external style sheets. But one problem that I highlighted is you can never have inline styles and inline scripts, right? That is a problem for web development as such. We can never do everything in an external style sheet. We might sometimes add a smaller script that can be run on a page load, right? So what happens when people introduce this on the first version of CSP, they had to do a lot of refactoring to remove all the internal scripts and move it external. So the CSP2 has come up with something called as a nonce. So what it actually says is, you can also specify a nonce value, which is basically something that the server comes up with. It's a random number that is generated by the server. It, as part of the policy, the server, basically as part of, by policy, as part of the response, when the server responds back with the headers, it also says, I accept only this nonce. And this nonce is always changes on every request. It's not a fixed value. It changes, it keeps changing. So what happens here is, the content security policy says I allow scripts also. I also allow inline scripts, but it has to have this nonce in place, which means you can also have an inline script, but you have to specify this nonce in place. So if you look at an attacker's scenario, when the attacker added a comment to this website, this CSS. He can never know what a nonce is because it keeps changing for every request. And this is a static comment which was created by him long time back. So when the browser executes it, right, it first matches all the inline scripts with the nonce. Only if it comes with the nonce, it will execute that script. It's something that's new that CSP has come up with. So that's the content security policy. There is on the XSS protection, there is one more header that we can have, which is XSS protection. This header came a long time before the content security policy. This basically helps us in. I told about two attacks, right? One is persistent XSS, another is reflected XSS. This reflected XSS can also be found by the XSS protection. So this is actually enabled by default in Chrome and Internet Explorer. So whether you respond back with the header or not, it will by default protect you from XSS protection, and it actually blocks the page from rendering. It not even show the page because JavaScript executes as once it gets loaded, right? This is one thing that we have to know. I'll move to the next header, which is on HTTPS. We know HTTPS is important, and we don't want to expose information when we talk to websites. I don't have a demo for this, but I can talk about it with Twitter as an example. So the HTTPS is bound to be vulnerable with man-in-the-middle attack. Let's say there is a link that is sent to you on an email, or you bookmarked a website. Taking Twitter as an example, I say I bookmarked the http://twitter.com without the S, and I just click on the bookmark. What happens is the browser just hits Twitter, right? And what the Twitter server responds back is, okay, the Twitter server says, okay, I don't support HTTP because I think it's not the right way to go about it. So please give me back a request with HTTPS, is what the Twitter server will say. So now the browser again requests Twitter with HTTPS, and the future communication will be on HTTPS. So this smaller part where the user requests with HTTP and Twitter responds with a redirect, right? That's where there is the probability of getting attacked. So let's say your router is hacked by a person and he watches your conversation or your browser for all the requests. So now you give a HTTP request, the attacker intercepts the HTTP call. This attack is called SSL strip attack. So he intercepts the communication, and what he does is he communicates with Twitter with HTTPS. So Twitter will think the user is actually giving me a proper request, and it will respond back with HTTPS. He'll intercept that, again communicate with the user with HTTP. So this will always be unencrypted, and this will always be encrypted. No way the user and the Twitter will be able to understand that they are doing things wrongly, except if the user looks at the thing that the browser highlights. The user not looking at it, he'll always be communicating with HTTP. So what does the header do? What the header does is when a person clicks on, types in HTTP colon Twitter, and Twitter gets the request, instead of doing a redirect, it also sends back a header saying, I want strict transport security. This is the HSTS header. It says, from now on, even if the user types in HTTP colon / the browser should never respond with, the browser should never request with a HTTP tag. The browser should always note till the max stage, right? Max stage, till this header is cached, the browser should always do requests with HTTPS, irrespective of the user's type. But yeah, with this solution, right, there is still a very small window of getting attacked. This is the first request. First time when the user requested Twitter and the Twitter said, okay, I am going to have it stripped, that window is still vulnerable. And this is a very corner case, and not everybody is going to be attacked with this case. But people have come up with solutions to that also, which is a site called hstsfreeroad.org, where you can go and register your site and say, okay, I will always want it to be strict. So whenever you add it to this site, it adds it to, there's some sort of procedure, and it adds your website to the HSTS list. Now what happens is, even the first call, right, whether the server responds with this header or not, the browser, Chrome browser and Safari and Firefox, always look at this list. And if our website is also part of this list, what happens is the browser never requests it with an unencrypted communication. It always do a HTTPS request. So that's about this header. So it's recommended you add this header to your website. Sniffing. So moving on to the next attack. So a long time back, when generally website servers, what the browsers expect is when a server gives a content to the browser, it also expects the web server to say what kind of content it is, whether it's an image or HTML or what kind or a JSON. If we can say the content type, right, it will be easier for the browser to say, render it properly. If it's an image, it will render it differently. If it's HTML, it will render it differently. But people, since there is no strict policy in place, people started sending out responses back without sending the content type header. So the browser was unsure of how to show the content. So instead of having different cases for different people, what the browser did is, okay, I'll always look at the content of the server response. And if it's an image, I look at the byte stream of that content. If it's an image, I'll render it like an image. If it's a HTML, I'll render it like an HTML. So it's a good thing, right? But what's the problem? When we have uploads in a web page, and an attacker is uploading a JPEG, what the attacker can do is he can actually create a JavaScript and a vulnerable HTML with JavaScript and upload it to the website with an extension called JPEG. So when he uploads it with the extension called JPEG, what the browser does is, okay, it looks at the extension, it validates, and it just uploads it to the server. And when this content is shown back to the browser, right, what the browser does is, irrespective of whether the server says it's a JPEG or not, the browser looks at the content and it finds that it's a HTML and it renders it like a HTML, which basically runs XSS problems. We get into XSS problems is because the attacker has crafted a HTML page like a JPEG page and JPEG image and has uploaded to the website. So the browser actually looking at the content and then interpreting whether it should do certain things or not actually has become a problem to people. So there is this header where we say, I don't want the sniffing at all. Please don't look at what my content type is. I myself will send out the content type to you, and please don't sniff. So there is this header called where you can say X content type options as no sniff. So the browser will not do this sniffing and all. It will render in what content type you want to render as. The last one is on privacy. So all this time we've been talking about security. Now this one is about privacy. If people have been interested in the usage, right? Even without our knowledge, we are tracked by different websites. So if as a website developer from your perspective, if you think the user's privacy is very important, you can enable this header called referrer header. So there are two things that comes up with our request. Let's say there is a Twitter blog, and from there is a redirect to my website. So from my website's point of view, I want to know from where my users are coming from, just to target such users. Right? If there are a lot of users that are coming from Facebook and Twitter, I can do more advertising on Facebook and Twitter and make people come to my website. So for that, what the browser does is it always adds a header called origin and also a header called referrer. Basically, both these things have the information about the source from which this link came. So if somebody clicked on something, clicked on my website from Twitter website, then I'll also have, also with the current URL, I'll also have which origin it came from. By this, we can do more analytics, but what happened is this referrer header started showing the entire path of the website. So if I'm looking at, coming to my website from Facebook profile page, and the entire URL from where the context, right, it's shown to some other website, which is a problem that people are not comfortable with. So what you can do is this referrer policy comes with a lot of options. You can say no referrer, which completely it hides the information about where people came from. So from your website, you don't want to send the information to another website on which page they came from. You can stop it from happening at all. Or you can say from I will just show you the website that I'm from, not the entire path. Instead of showing the internals of the entire website, I can just show, okay, this request came from my website.org, not from so-and-so post and so-and-so location. So different options to it, and we can add all of them and fix the privacy. You can use this, there is this, what's it called, canIuse.com. Which basically talks about the supports for the different headers. If you look at referral policy, it shows which versions of Chrome support, which versions of Firefox support. Because of there are certain things that are not supported. You can look at it from here. There is also one more website called securityheaders.io. It basically validates whether your website is good. Look at so it gives a grade, and it also checks for the different headers that are added. You can basically validate the website. That's all I had. Just credit to Murli, who had helped me in developing the application. He's not here.
Thank you, Deepthi. We can have a 2-minute, if you have any questions, please call out. And in the meantime, others, please write down the feedback. We'll be breaking out for lunch after this. And by the way, all the decks that we actually project now and all the reference information will be made available and published in the Vodka Chennai page, right? So that we will do after the event, and we will send a note from Meetup to all of you so that you can go and take it from there. So Deepthi was talking more from a dev perspective, right? Adding headers, right? What does it mean to us? When I say us, QAs here. Would we get to go and add headers? Yeah. So basically getting familiar with all these headers and checking whether each of our calls that we make from our application, right? Does it have all these headers in place? That is a call for action that we can take on ourselves and try to do that in our projects, right? Even the get calls, right? Then the simple calls. Nowadays there is an option to actually do a pre-flight option, right? A pre-flight call, an options call, even before the get call happens, right? In our project, we are doing it, right? So getting familiar with these headers and all the different patterns and all that, so that we can ask the right questions as and when each endpoint gets built in our project. So look at it more from a security angle and check whether the appropriate headers are present for each of the endpoint when it gets introduced in your project.
So for example, right, I run my test every day. I automate test every day, and basically I do all the functional assertions. Right, as it runs, is there some kind of library that you can recommend where it also ensures these kind of checks are also done?
Yeah, so that's a very good question. And today is the fourth session that we have, right? This is the automate security testing using ZAP API that touches on this topic, right? So we can do an automation of these things where we can check whether some of the fundamental headers are missed out, right, in the calls that we make as part of our, let's say, automation test as well, right? So that is also possible, and we can also do that. But in addition, this is something that we need to take little more, seriously. And I would say, call it as a security set of scenarios or assertions that you have to do whenever there is a story or a card where you actually introduce a new endpoint, right? You need not worry in other cases, but whenever we check the new endpoint that gets introduced has all these things, then we should be, good enough. Okay, so with that, it's already 1. So please go ahead for lunch. Once you come back, we will have people sitting here to help you out with installations for the next 2 workshops. So afternoon, we have 2 workshops back to back. So as far as possible, if you can complete the lunch and come a bit early, say 15-20 minutes early, and try to ensure your setups are all done, that could be helpful. Thank you. Yeah, so everyone would know where cafeteria is. Yes, please proceed.